All right, so this will be the quiz 5.4 key that I completely recorded without sound. So number 1, we'll go through these quickly. They want the integral from 1 to 3 of f of x. So the only information you're given is actually g of x, so we got to make a relationship back to f of x. So if f of x is g prime, so if I find g prime, which is 2x minus 3, then I can substitute that in right here and put 2x minus 3 dx. My antiderivative is actually x squared minus 3x. Notice the plus 4 is not there. If you use it by accident, you'll still get the correct answer. So f of 3 would be 9 minus 9, which is 0. F of 1 would be 1 minus 3, which is negative 2. So you get 0 minus negative 2, and the answer is positive 2. Letter C. Next one is, say, number 2. For this guy, it's a quotient rule. So remember, you can't do anything with a quotient rule. So what we'll do instead is simplify it so it's no longer a quotient rule. You actually get 1 to e of x minus 1 over x dx. My antiderivative, I'll come down here, will be x squared over 2 minus ln of x. So f of e would be e squared over 2 minus ln of e. Ln of e is the same thing as 1. F of 1 would be 1 over 2 minus ln of 1, which is the same as 0. So you actually get e squared over 2 minus 1. This gives us 1 half. So you end up with e squared over 2 minus 1, and then minus the 1 half. So you get e squared over 2 minus 3 halves, which I believe is letter E. Next guy. This is the one a lot of people lost some points for because I asked that you actually show your reasoning. So when you see this statement, the first thing you should do is take the derivative of both sides, and you get g prime is equal to f of x. So g prime is equal to f of x. Let's see. So if I get the g prime sign chart, then I can figure out what f looks like. So I'm going to make g prime sign chart right underneath here. So I'm going to look at slopes because here to here I would need to take a slope. So the slope is 0 at this point. At A it actually looks like it's 0, and at B it looks very close to 0. The slopes before the top point, the maximum, are increasing. Sorry, not the slope. The function is increasing, so the slope is positive. The function is decreasing, so the slope is negative. So the reason why some people got it wrong is now that you have that sign chart, which was g prime, we now need to somehow use it to graph f. Now, the sign chart is for its graph itself. So what that means is the pluses mean that f is increasing. The minus means that f is decreasing. No, I'm lying. I'm totally lying. The plus means that f of x, because we're looking at y values because it's the same function, is above the x-axis. And then the minus means that it's below the x-axis. So I need the function to be above 0 and then below. And the only function that does that is this one. Here it's above, here it's below, and there's your 0. Number 4, I want to find f prime of 2. So starting with the question, I need to first start with f prime. So I'm going to take the derivative of both sides. And when I do that, this 2x drops in for t, both t's. And then I'm going to actually multiply it by the derivative of the inside, which is 2. So f prime of 2 would be 4 squared, which is 16, minus 8, and then the whole thing multiplied by 2. I get the, did I do that right? I feel like I did not. 4 squared is 16. 2 times 2 is 4, not 8. And I get root of 12 multiplied by 2, which is 2 root of 12, which is letter E. If you forgot the derivative of the inside, you would have gotten D. Number 5, shown in the figure, I want f of 3 minus f of 0. How would that be related to the f of x function? Well, if you take the integral of f of x from 0 to 3, that would give you big F minus, f of b minus f of a. So what you want to relate is the fact that we have this information. The net signed area from 1 to 3 is 2.3. But we need the integral from 0 to 1, so I have to add in this little box, which is 2. So 2 plus 2.3 is 4.3. Number 6. Let's see. We want to do the integral from 0 to 5 of 3 plus 2 times the integral from 0 to 5 of f of x dx. This you can do two ways. You can do the antiderivative as 3x. F of b minus f of a would be 3 times 5 minus 3 times 0. That's one way. The other option you have is the fact that it's a rectangle with a height of 3 and a width of 5 minus 0. They do the exact same thing. The height of 3, 5, there's 0. That would be the area in which we're finding. The second part, the integral from 0 to 5 would be 6 plus 4, because I'm doing the integral from 0 to 3 plus the integral from 3 to 5 is the same as the integral from 0 to 5. So I get 10. So my answer becomes 15 plus 20, which is 35. Letter D. If you do it incorrectly and just add the constant 3, you'll get C, the other incorrect answer. The pre-response question, the first one I'll do, the second one you already have in your answer key. The first one says, given that you have the function ln of x sine of x, so I know that this is ln of x times sine of x. This is a non-calculator question. I have here endpoints of 0 and 2 pi. Oh, actually, sorry, only one-sided endpoint. Okay. And I have this information right here, which I'm going to change that to g prime is equal to f of x. And now we know that this is the same thing as g prime. Now I'm going to read the question. So the questions are g of 1. Starting off with letter A, g of 1 is the same thing as the definition 1 to 1, which I'll just shortcut and say 0. G primed of 1, well, this is the g primed graph, so if it's the same as the graph, then we're looking at the y value at 1, and the y value at 1 is 0. Letter B, when is g increasing? G increases when g prime is positive, so I need a sign chart. We're going to do a sign chart of g prime here, but that means I'm doing y values because this is the actual graph of g prime. So the y value here is undefined. Here is 0. At here it's 0. And here it's 0. Now this one's easy. That's 2 pi. This one is 1. Here's the value I don't know. I'll find that in a second. The y values are negative. The y values are positive. The y values are negative. So I don't know the value, but that means there must be more information. Well, here's the information. Here's what g prime is equal to. Set it equal to 0. ln of x is equal to 0. Sine of x is equal to 0. ln of x is 0 when x is equal to 1. Sine of x is equal to 0 when x is equal to 0, pi, 2 pi, and so on. So this must be pi. So g prime is greater than 0 when I go from 1 to pi. Letter C. Ask, find where you have an absolute min. So I'm actually going to do this over to the right. I hope that I have enough room. So I want to find when g has an absolute min. Let's do this again. All right, so minimum of g means I'm going to need g prime equal to 0. We actually already did that a second ago in part B. So g prime equals 0 when x is equal to 1 pi and 2 pi. I know that I want a minimum, and the only minimums happen at 1 and then again at 2 pi. So I need to find g of 1, which happens to be 0, and then g of 2 pi, which would be the integral from 1 to 2 pi of the function that's up there. So I'm finding this all from this definition that was given. Now, g of 2 pi is 1 to 2 pi. Now, net signed area, if you look at the purple, it's definitely negative. Therefore, the absolute minimum happens when x is equal to 2 pi. Letter D. These are definitely fake areas, so if you're going to show this problem to anyone else, they're going to tell you that these areas are obviously wrong. but I just wanted to shortcut and use those values. I want you to write an equation of the normal line at x equal to 2 pi of g of x. So not only do I need g of 2 pi, I'm going to need g prime of 2 pi. And then I have to remember that I want the normal, not the tangent. So g of 2 pi. We know it's negative, but now I actually gave you some values from 1 to 2 pi. And the values that I need is the fact that the area of B is 5 and the area of C is 11. So the net signed area would be positive 5 minus 11, which gives us negative 6. G primed would be the y value at 2 pi, and that's obviously 0. So the equation of the tangent line would be y plus 6 is equal to 0 times x minus 2 pi. But when I try to do the opposite reciprocal of the slope to make the normal, you end up with this. The reason why that happens is your tangent line at 2 pi happens to be a horizontal tangent. Therefore, the normal has to be a vertical tangent. Vertical lines all have the same type of equation, x equals, and in this case, it's x equal to 2 pi. All right, there you go.